Hello everyone, welcome to the webinar. My name is Clarisse. I work here at iBwave in marketing and I will be your host for today. So today's webinar is on private LTE networks, which has become the hot topic in the wireless industry. And I'm joined by Dean Bubley, industry thought leader and founder of Disruptive Analysis. So just before we get started, I want to cover off a couple housekeeping items. So the webinar will be recorded and sent to everyone after the presentation. And also feel free to ask questions to our presenter by using the GoToWebinar question box. We'll have a question and answer time at the end of the presentation. So now I'm going to hand the microphone off to Dean. Hello, Dean. Thanks for being with us today.
Thank you, Clarisse, and welcome everyone to this session on private LTE and CBRS. I'm actually the only speaker on this webinar today. There isn't another iBwave presenter, so I'm going to be running solo for about the next 40 minutes and then taking some Q&A after that. One thing I should point out on the Q&A is I am not a specialist in the product side of iBwave or indeed their product's use. If you do enter questions that are product related, either an account manager or one of the other iBwave crew can get back to you after this separately. So to kick off, for those of you who don't know me, I'm an industry analyst and consultant. My social media alter ego is Disruptive Dean, because I tend to be somewhat contrarian. I've actually been following the evolution of private cellular networks since about 2005 and small cells since 2001. And it seems to be that the often promised dawn is finally coming in the era of sort of late 4G and early 5G networks. And one of the things that I've been doing a lot over the last couple of years is looking at the use cases for private networks, the definitions which are changing, the roles of service providers, both traditional mobile network operators and new managed service providers for perhaps certain verticals. And I've also been watching, as well as the radio side of the networks, a lot of the associated elements that go to make up networks. And I'll talk about the components later on. So it could be the core network, it's the transport, fiber, backhaul, front haul. Recently, there's been a lot of emphasis on Open RAN and other forms of virtualization. And then there's a lot of sort of regulatory side to this. The spectrum policies of different countries are changing rapidly at the moment. And then we've also perhaps got other issues around roaming and the emergence of wholesale players called neutral hosts. And I'll talk through some of that over the next 40 minutes. So first off, to set the scene, I want people on the call to imagine themselves in, let's be optimistic, 5 years time, maybe 10 years time, and you've got a self-driving car. It's yours rather than being owned by a ride-sharing company. And you've gone to a hotel or a conference center. You've left the car in an underground car park. And the next morning, you use your phone and the app on your phone to say, come and meet me at the lobby. But the car is parked 2 stories underground in the car park, and there's no cellular coverage, and the car doesn't know how to connect to Wi-Fi if there is any. And unsurprisingly, the car doesn't know where it is, and because there's no GPS, and you can't contact the vehicle. And that's sort of one sort of thought experiment here. The question is, whose responsibility is it to fix that sort of problem? Is it the hotel? Is it the car manufacturer? Is it the mobile operator that the car is using? Is it the outsourced company that does the parking systems management? Is it the organization that does the in-building wireless for the main part of the building, but historically hasn't needed to put as much emphasis on the underground parts? Or is it some sort of other third-party service provider that's involved in the IoT connectivity layer? The point is that at the moment, there are few organizations that understand all of those parts, let alone take responsibility for them. And also, when you consider that all the other vehicles are using different networks to yours, you start to grasp the scale of the problem. And so arguably in this situation, it ought to be the venue owner that takes responsibility for network connectivity. Perhaps they can't persuade all of the mobile operators to contribute to the cost or agree to the design of the coverage. And so perhaps one solution in the future would be a private network, private cellular network, which perhaps the vehicles could roam onto. So that's just setting the scene. But really, this is just like one individual use case of literally thousands and millions of wireless connectivity scenarios that we can consider for the future. This chart, some of you will have seen it before when I've presented, and I won't apologize for using it again. In a way, it's very complicated, but in the actual fact, it's quite simplified. I've only put 6 dimensions onto a 2-dimensional slide. It sort of really illustrates that there are so many ways of slicing up the future wireless landscape. We used to talk about coverage, talking about range of different network technologies, speeds, latencies. But going forward, we also have to start thinking about how important certain applications are, whether they're critical to a business, whether perhaps they're even safety critical to a person or who's using a device, or so perhaps a robot in a factory or something like that, or a piece of machinery. And we also have to start thinking more about the alternative business models. We used to, well, what I've got on the chart, CSP, communication service providers, MNOs, mobile operators, typically national based, providing mobile services for smartphones and some classes of connected device. We're also used to the Wi-Fi model, which is primarily a private ownership model, where companies put their own Wi-Fi access points around their building, much in the same way as historically they have their local area networks. What's changing is those two sort of binary options are being added to by new approaches of wholesale, of amenity networks for perhaps metropolitan area, third-party service providers involved as well. And the spectrum that they use is not just a simple choice between licensed spectrum on a national basis for cellular networks or unlicensed for Wi-Fi, but there's a lot of sort of variations that are coming out, and I'll talk through that in terms of local spectrum, which is suitable for 4G or 5G, new bands for Wi-Fi, various approaches to shared spectrum, which may have different users and different technologies in different locations over time. And we've also got a lot more network technologies and ways to deploy them coming online as well. Later versions of Wi-Fi, but also new forms of low power wireless for wide area. The satellite industry is a huge hotbed of innovation at the moment, and various other techniques and technologies as well. So just to sort of give a bit of context, when we start talking about the different ways in which cellular networks can be built, we used to talk about mostly national mobile operators. Some countries like the US have smaller regional players as well, but most countries in the world have 2, 3, or 4 big national operators, and perhaps some what are called virtual operators, which are usually additional brands which use one of the main networks as their platform. But we're starting to sort of enter into a new landscape where there is different forms of service provider who are taking advantage of new spectrum regimes, cheaper equipment, more software and virtual networks, and availability to get a lot of those functions delivered as a service or from the cloud. So what we're talking about here is primarily private cellular networks. And by that, I mean cellular networks, typically 4G or 5G, that are owned and operated either by an enterprise like a manufacturing company, perhaps a venue like a sports facility or airport, managed service providers, perhaps that are dedicated to a particular vertical. And then we also have the mobile operators that are looking at sort of hybrid approaches of whether they can provide a more localized, on-premise, dedicated or semi-dedicated network, either reusing their spectrum or their radio network or parts of their core network infrastructure, but optimized for a particular individual site or company. A couple of other categories that I'm not really going to talk about much on the rest of this session are what I'll call microcellular networks, typically communities or small cellular networks that are built for villages or islands or perhaps entire cities, where either because they see a benefit in the ownership of those assets, or perhaps they are poorly served by the commercial mobile public operators today, they look to build their own resources as well. I'm seeing a lot of interest in, for example, metropolitan authorities and local councils in starting to look at building their own cellular networks for their own requirements, those of their citizens, and then sometimes to allow the national carriers to roam onto them. The last one is overlaps with that, and that's what I call neutral host cellular. That's something that I've also looked at a lot in the last few months, and that's a new wholesale play where a third party gets access to spectrum or runs on behalf of the national operators. They run a network sharing platform, and essentially it's a wholesale play where you could imagine that perhaps in a rural area or inside a building, a new provider, which could be a tower company, it could be the venue owner themselves or a specialist third party, acts as almost like a local mini operator, either providing additional capacity or just actually coverage in a place which historically has been uneconomic for the national operators to provide. And that certainly will play in building in some parts of the world as well in future. But I'm not going to go through that in detail today. So why would an organization, let's say an enterprise, want its own cellular network? And really there are four big categories of motivations that I see. There's improvement of coverage, greater control over how a network is designed and operated, cost, either in terms of their cost of connectivity directly or elsewhere in their business, and then also as a revenue source of compensation. Is there a new business model that they can actually use to get money as well as save it? So on the coverage side of things, there's a number of challenging environments. And obviously on this call, I'm focusing on in building and just to a degree industrial and offices, but there's also a lot of interest for private cellular for rural areas, particularly for utilities, for example, that don't have they have assets over a hugely wide area, which perhaps is broader than the traditional network operators who don't tend to put coverage in places where there are no people. Along road and rail side is another one which is interesting and that I'm seeing a lot of interest in, especially as 5G will be at high frequencies, and it's unlikely that all of the carriers in a given country will put their full coverage along every mile of highway or trackside. Metropolitan areas is another challenge. Perhaps there's not enough capacity in really dense areas. Perhaps there are specific use cases. I mentioned the local authority maybe wants to run its own IoT networks. And then the last one I would also talk about is emergency services, public safety and military, which actually has used private cellular for quite some time. The control aspect of this ties in particularly with the more high-end users, whether that's government organizations, but also, for example, manufacturers who cannot afford downtime if they're using cellular connectivity inside their factories or perhaps between the buildings on a campus for robots or what are called automatic guided vehicles. Think of a self-driving forklift truck. They have requirements on security, on what I call sovereignty, ownership of the data. Rightly or wrongly, a number of organizations still don't really trust cloud-based service, particularly when it's business critical and they can't get, if you like, liability insurance where there is a third party involved. There is certainly a subset of enterprises that want to have their data under their own control in their own servers on site, on premise. I think one of the other interesting things here is that there's a variety of different views on what I put down as life cycle. So I was at an event yesterday with some utility and government organizations who are talking about private 4G or 5G networks because they don't want to get locked in to the upgrade cycle for normal mobile operators. Yeah, particularly utility companies want their assets to last for 20 years, 30 years, and they don't want to be persuaded to upgrade to 5G, then 6G, then 7G, with equipment that perhaps is no longer being maintained or supported. Whereas if they own it, perhaps with customizations, they can make their business plan work over much longer and extended periods. And the other side to this is that some organizations want to run their own private schemes for prioritization, how they define quality of service, uptime, reliability, the metrics that perhaps are slightly different to those that run on the main public network. And whilst it's possible for a service provider to run these as a managed services or perhaps to install them on behalf of enterprise, a lot of the larger companies are used to running their own networks, the fixed line, various forms of wireless in a factory or an oil refinery, and have sufficiently skilled staff that they feel that they can optimally run their connectivity assets and operational assets better in a way that fits better with their particular vertical and their particular requirements. So an example might be a mining company where they have explosives on site. And so clearly there's a health and safety angle to what radiates at what power in what places at what time, and there's clearly an imperative there for more local control. The cost angles are, again, really vary by sector, by size of organization. So one of the things that's getting talked about a lot is next generation factories and industrial environments where they want to have flexibility and agility, perhaps to move process machinery around the campus or the plant without having to recable every time they reconfigure their operations. Another one, this replaced legacy LMR. LMR here is land mobile radio, sometimes also called PMR, private mobile radio, essentially two-way radio systems used in everything from blue light services to utilities to transport hubs to security guards. And the ability to have a private LTE network that supports push to talk is a real desire in some of those sectors, although some of them are also pretty conservative, so we may see a transition phase where they are dual mode first. A number of organizations want to reduce their reliance on the telecom operators, either because they don't want to be paying per gigabyte, especially on their own sites, or simply because they feel that they retain more control by insourcing the connectivity if it's strategically important. And the last column on compensation is an interesting one. I'm starting to speak to people in a number of industries that don't just want to save money, but they're looking at private cellular as a way to actually derive additional revenues in future, either from roaming deals with the national operators, perhaps working with MVNOs or international operators. You could imagine a hotel cutting its own dedicated roaming deal with a Japanese or Chinese or German telecom operator for inbound visited guests. You may well find that there is additional sources of revenue available from government for local projects. There might be offload revenues from the traditional mobile operators who are looking for extra capacity. And there are also possibilities around localized fixed wireless access. So I think we'll see a lot of innovation here. And whilst the initial phase of private cellular has very much been about cost and control and coverage, I think that if we come back in 5 years' time, we may well find that the self-driving car in the car park is perhaps paying the building owner to some way to recompense the cost of installation. So in terms of where we are today with private LTE, there's probably about, it's a little bit difficult to calculate, but I'd estimate of the order of, say, 300 or 400 private cellular networks around the world, different sizes and scales and scopes, but they tend to be outside of what you could call a carpeted office. They tend to be field workers or Internet of Things devices. So on this picture, there's a sort of a construction site where you have the workers with two-way radios. There's quite a lot of military and tactical use. Often these are self-contained small cellular radios that might be on a battlefield or perhaps used for disaster recovery. Disaster and evacuation in a catastrophe zone. The picture of Concorde in the bottom left is Heathrow Airport in London, where I'm from, and that has a private LTE network for the field workers around the airport. And then oil and gas and mining have been quite important. And the one on the top left is an interesting one because this is a fulfillment center for an online retailer, again based in the UK, but is now exporting this concept around the world. And they decided that private cellular was more capable for this particular application of robots on tracks, picking and choosing products from trays underneath the warehouse. It was essentially capable of more than Wi-Fi was in terms of the density of the robots, the speed that they moved at, and the latencies that were needed. And so that's the sort of thing we can think of going forward of slightly innovative use cases around private cellular. What we can expect next year and beyond. And I'll particularly reference the US here because, as I'll mention a bit, there's a new spectrum band and ecosystem called CBRS that's coming first in the US, and we may see similar things emerge elsewhere. And this is going to allow potentially for a much broader set of use cases for private cellular. One thing I would say is, first off, it is going to start mostly with private LTE, 4G. There's a lot of interest in private 5G, and it's certainly a catalyst, but I think a lot of the early deployments will stick with the tried and tested 4G networks, not least because that's where there are insufficient skills, people, the ecosystem is more mature, all of the components have quite a competitive manufacturer supply chain, and there's greater channels to market. We're seeing a lot of interest in 5G and private cellular, but I think that that's going to take longer to evolve. We'll see trials, early deployments over the next 2 to 3 years, but the real sort of upswing in that is probably still a number of years away. And so we'll see hotels, convention centers, sports stadiums, other forms of manufacturing plant start to use private LTE for a lot of different reasons. And some of this is going to be driven by humans, people with smartphones who are using local connectivity. Perhaps it could be the guest room cleaning staff in a hotel, or instead of using walkie-talkies. Perhaps it's going to be visitors on site in a convention center, or certainly in a sports stadium. There may be new experiences that are delivered locally over an optimized private cellular, perhaps with edge computing to give multiple views of the field, instant replays, perhaps even VR and AR experiences as well. But I think that IoT is also going to drive a lot of demand, whether that's for asset tracking, protecting particular IoT devices that today connect via Wi-Fi, which may get congested, and using the private cellular network as a slightly more controlled environment for critical IoT, or business critical. So perhaps it could be in an airport, it might be the payment systems in the duty free. It could be for the check-in desks or a bunch of other applications that are on the airfield itself rather than indoors, the maintenance hangars and so on. So what this translates to is this number of going from hundreds of networks to potentially thousands or tens of thousands of private networks. And there's an inverse correlation with the scale. So it's worth pointing out that private networks can be anything from an individual building, even a ship or a private aircraft can be a private cellular network in its own right, with its own core, and perhaps even its own numbering domain as well, right up to a nationwide or statewide utility provider or a metropolitan authority or a smart city may have its own cellular network. Perhaps the real sweet spot is in the middle, where it's going to be the hospital campuses, complexes, the universities, ports and airports. Today, there's a certain amount of use in industrial, but I think that that's going to expand from the really isolated industrial today, like an oil rig, into more mainstream factories. And certainly the event I was at in Germany this week was looking very much at private cellular for mid-sized industrial organizations that want to have an additional capability as well as their existing Wi-Fi and their existing cellular networks. So in terms of the technical enablers here, there's a number of different ones, but the one that I think is most interesting and that a lot of people on the call will have picked up on is the bottom circle here, the local and shared spectrum models, which are emerging in different ways around the world. And I think that this is where this topic CBRS comes up. Historically, cellular spectrum has been provided usually through auctions, sometimes through what are called beauty contests, to mostly national mobile operators that have paid very large sums for coverage, or the right to give coverage, and then subscription-based services, particularly to humans with smartphones on a typical mobile basis. What is now happening is two things. First off, most new spectrum bands for 4G and 5G already have other users in the band who can't easily be cleared, which means that some form of sharing will be necessary, even if it's just to give those bands as well to the MNOs. They will have to work with or work around the incumbent networks. It could be fixed links, it could be satellite providers. There's a big conference the last month run by the ITU called World Radio Congress that was looking around, among other things, how the future 5G networks can coincide and coexist with all of those other applications. But what's also interesting is happening is a number of governments have realized that the motivations of industry, of rural coverage and other users is not adequately being serviced by today's mobile operators. And perhaps to encourage them and perhaps also to enable completely new use cases, we're seeing a number of markets that are providing more localized spectrum suitable for 4G or 5G. And I'm seeing that happening in the US with CBRS, UK, Germany, Sweden, Netherlands, Japan. In some ways, China does this as well, Hong Kong, and other markets as well. Most industrialized countries, larger ones, are looking at some form of new spectrum. The other thing that's happening is this 4G to 5G transition. Important thing here is that it's not all about 5G. It's about the technology innovation in the 5G era. And what I mean by that is we're seeing virtualization, whether that's in the core network or on the radio, which is bringing down prices. It's perhaps lowering entry barriers for smaller network operators, as well as concentrating their minds on what the use cases for 5G might be in future. And then I've also already mentioned the Cloud RAN, but more generally, we're seeing small cells, which have been around for nearly 20 years now, become more easily deployable, easily manageable, able to support multiple operators more easily. And certainly for some environments with lots of guests and visitors, there needs to be multi-operator, not single operator. And all of the other moving parts of the system are getting easier. And collectively, this is making it more feasible for private networks of varying types and provided by various service providers or the enterprises themselves to crop up. So in terms of what bands we're talking about, the US CBRS band is, I'll talk in a second, but it's in the 3.5 gigahertz range. We also might see a slightly higher band, the C band, over the next couple of years. There's a lot of debate going on within the FCC and other bodies as to where that'll go over the next few years. That's currently used. C band is currently used by the satellite industry predominantly. In Europe, there's a real mix, but mostly mid-band spectrum, slightly different ways it's being organized. So Germany has dedicated 100 megahertz between 3.7 and 3.8 gigahertz for mostly industrial use cases on a localized basis, particularly suitable for manufacturing sites and campuses. The UK has now a number of different approaches to local licensing of spectrum, small slices at 1.8 and 2.3, LTE, a much larger slice at 3.8 to 4.2 that's available for low power or mid power licenses, although there's not many devices available today. Indoor use at 26 gigahertz is an intriguing one. And then there's also this concept of secondary licensing, which is ability for companies to apply to use what you could think of as existing national license spectrum, but in areas where it's not being deployed by the main mobile operators. And that's quite controversial, but in certain particular contexts, it could be a benefit to both the host operators who may get paid for it's not quite leasing of their spectrum, but it's like secondary licensing, but also because it absolves them from the responsibility for rollout in those locations. Local leasing of spectrum is quite common in parts of Scandinavia and also places like the outback in Australia, and we're seeing various other approaches taken in France and Japan and others. In addition to this, there's also unlicensed spectrum suitable for cellular. 5 gigahertz band, which traditionally has been used for Wi-Fi, is now also able to be used for LAA, which is more aimed at the mobile operators who have another existing licensed cellular band to anchor it in, or multifier, which is an approach which is unlicensed only approach to 4G or soon 5G. And there's some other bands that are coming as well. So moving on to CBRS in the US. And CBRS, some people will be already familiar with this, but I'll give a quick overview of how it works and what it involves. Essentially, there's a band between 3.5 and 3.7 gigahertz, which today is mostly used for a few fixed links around the continental US, and it's also used by the US Navy for some of its large ships along the coasts. And obviously you don't get too many aircraft carriers in Nevada, so there's a desire to make it a more efficient use of that spectrum away from the coastline, but also potentially at the coastline when it's not being actively used for those purposes. So what's been set up is a 3-tier system where the existing incumbent users get the preemption rights to use the spectrum when they want. And then the rest of it is divided into 2 categories, what are called protected access licenses, which are dedicated use, which will be up to about half the band. And the auction will for that, the auctions will take place in the middle of next year. And we'll see who the buyers are. They might be traditional carriers, they might be enterprises, there might be new categories of entrants as well. And then there's if either all of that protected license allocation isn't used up at a given place in a given time, or just the other 80 megahertz that's left over, there's what's called general authorized access, which is sort of a quasi Wi-Fi type approach to spectrum. It's not quite the same as unlicensed spectrum. It's essentially there's a database lookup function to check that it's appropriate to use that band in that place at that time. I'll talk about the database in a second. And the US is being divided up into 3,000 county level territories. There's quite a lot of wrangling within the regulatory process to the size of these areas. Some parties wanted it larger, some smaller, and this was the compromise. I mean, it'd be interesting to see. We might get some of them broken down into sub-chunks with a sort of secondary marketplace. So we may get smaller and more granular network allocations at another tier. So the way there's a lot of information online and some really good presentations and webinars by the CBRS Alliance themselves. So I'm not going to go through all of the internals of the system, but essentially what the main functional blocks of this are is that around the coastline there's essentially these environmental sensing locations, which essentially are there to detect if the US Navy is using the frequency at any particular point in place. They don't want to obviously advertise in advance where their ships are going to be, so it's important to have this sort of essentially sensing capability. That, as well as the other data, such as the use of the fixed links, is held in a number of databases known as Spectrum Access Systems, SASs. There's a number of competing SAS providers. In the initial commercial deployments of CBRS, there are 5 that have been authorized so far, and they're from cloud companies and specialist wireless companies, and that would be an interesting market because those providers are quite important in the ecosystem and will likely end up being quite hubs for a number of the other bits of the value chain around themselves. And there are a couple of different classes of the base stations are actually called, or access points are called CBSDs, CBRS devices, and there's an indoor version called Class A, which are low power, which might be tied together with what's called a domain proxy, which is sort of a local controller if you have multiple of these in one building, or the outdoor higher power ones called, which are Class B. And they connect to the SAS databases to check that they are allowed to use radio resource in a given location. And there's a certification involved in installing them for the installers. So it's going to be quite tightly coupled. The security model is very well thought through. And I think that unlike a number of countries, this is not just the radio network, but it's essentially an entire ecosystem of the access point providers, the SAS companies, the companies doing core networks. There's a lot of thought that's gone into the various parts of the puzzle to create all the different use cases for private LTE or for the other use cases. And this is one thing that is important to note about CBRS is this isn't just about private LTE. Some of the main users of CBRS spectrum will be the conventional cable operators, conventional mobile operators, essentially using this as cheap extra spectrum, particularly for outdoor use. We also see fixed wireless access using these bands. Perhaps the cable operators might do it. You'll see rural networks being set up with CBRS spectrum, as well as the indoor use case. And I think that this is a little bit of an unknown at the moment as to sort of what the balance of indoor versus outdoor, and whether this is primarily going to be driven by the mobile operators, the cable guys, the wireless ISPs, indoor neutral host providers, enterprises themselves, all sorts of other industry participants. And I think it's going to take a year or so for this to settle out. But I think that one of the reasons that the US CBRS ecosystem is so vibrant is that there are so many different use cases. And I think that that's going to lead to quite a lot of innovation over the next few years. And one of the things I would like to see is the ecosystem for CBRS being replicated in other parts of the world. And just to point out how complicated all of this is, if you actually dig into what it takes to build a private LTE or 4G or 5G network, there's a lot of components. Now, essentially all of these are small mobile operators, and so they have all of the bits of technology that go into creating a normal cellular network, from the devices to the radio to the core networks, SIMs and what RSP is, remote SIM provisioning for eSIM. The core network is a critical part of the puzzle here, which handles registrations, policy, security, and so on, mobility. And that's whether that's the existing 4G EPC core or the 5G standalone new core, which is just still being finalized and is not yet fully commercialized. You also see touch points with edge compute. In some scenarios, there'll be need to do roaming and interconnect with a public network. And that then brings in question marks about what happens with numbering and so on and so forth. And there also needs to be suitably skilled people and suitable tools to install, operate, deploy, plan these type of installations, which could be single building, or they could be wide area. So this is going to take quite a long time to mature, in my view. It's also worth saying that the fully private cellular networks are not the only answer to a lot of these use cases. Although here I've talked about an enterprise deploying its own network, or perhaps having a campus network from a mobile carrier, there's a lot of other ways to solve certain problems that are being explored. I'm seeing a number of enterprise-focused virtual networks, enterprise MVNOs, even some companies becoming their own MVNO. So there's a large shipping company, and there's a large technology manufacturing company I know that gives its staff its own SIM cards, although it's not actually running the radio network. It's essentially buying it wholesale from one of the normal carriers. And in the middle of this, there's a huge amount of interest in this concept called network slicing, which particularly comes into fore with 5G, later versions of 5G. where it becomes possible to create partitions of the 5G network suitable for certain purposes, applications, or locations. And so we will certainly see a lot of discussion, although I have my doubts on how practical this is going to be for many enterprises, about whether or not they want to deploy a standalone slice of a cellular network for their requirements. Now, that gets problematic where you have an enterprise which is both has its own on-site, on-campus requirements, but also gets cellular coverage over a wider area from the, if you like, the main macro network. And it remains to be seen how well this can be coordinated to give the enterprise true control or true differentiated services within its own premise, but we'll see. I also think we're going to see a lot of other new classes of service providers, such as managed providers in individual sectors, like it could be hospitality or oil and gas and mining. It could be government, who are large enterprises in their own right, but they're perhaps managing production machinery in factories. So I could quite imagine, if we come back in a few years' time, that, I don't know, Siemens or Honeywell or Rockwell or ABB or Philips or Bosch or someone is running multiple mobile networks on behalf of their industrial customers using local spectrum wherever that's available. And I think we'll see all sorts of hybrids and also mergers and acquisitions to come. So it may well be that some of the early managed service providers get bought out by the mobile operators. I haven't mentioned Wi-Fi that much in this. One thing that absolutely will not happen is cellular replacing Wi-Fi for any meaningful sense of the word. I know a lot of people try to position it as a battle between one and the other. My view is that in many ways Wi-Fi is getting more important and more capable, especially with the advent of Wi-Fi 6. And I think that in some circumstances Wi-Fi will actually take more share of communications from cellular. I think particularly in the home, where mesh Wi-Fi is becoming more important, more capable, more intelligent, is, even though people will have flat rate data, having flat rate data on 5G on frequency bands that don't go through the wall won't help very much. So I think that that's the residential market is going to be solidly Wi-Fi for the foreseeable future. Carpeted offices, again, I think we're not going to see too many printers and video conferencing terminals and coffee machines and so on with cellular radios in them. Not laptops either, although there's a few cellular laptops. Despite the hype, I expect it's still only to be a few percentage points in the medium to longer term. So Wi-Fi and well-designed Wi-Fi in enterprises and enterprise corporate offices will remain important. Where I think that 4G and 5G will become particularly important is in the sorts of industrial markets we've discussed. I think that in visitor-centric locations like retail and hotels and hospitality, cellular often makes more sense, because if you can provide multi-operator coverage, it makes it easier for the end user. And I have to say, I'm not a big fan of complicated Wi-Fi logins. I think that the Wi-Fi industry does itself a disservice by, in some locations for hotspots, demanding social network logins or complicated, give us your email and your preferences and your age and all the rest of it. I think people will just use cellular instead in those locations. So I think that the Wi-Fi on an enterprise point of view will keep being the mainstay of what I'll call local IT and internet and LAN access for laptops, potentially users' phones who visit somewhere regularly. Where I think that the cellular networks, whether it's today with public 4G and 5G and in future with private, this is very much a snapshot of today. And if I was going to change this color plot for 3 years' time, that column with private 4G, 5G would have a lot more orange and yellow in it. I think that the Internet of Things use cases, voice connectivity, perhaps using push to talk, and there's this term OT, into operational technology, particularly in industrial or critical use cases, which I think is perhaps not as suited to Wi-Fi, particularly where there's low latency requirements or particularly high reliability. So this is a complicated chart, which I probably don't have time to go through now. If people want to talk to me offline, then I can discuss it in more detail. So last couple of slides before I turn over to questions. I think one thing that set all of this in context is a lot of people in the cellular industry talk about 5G transforming industries. But I think what a lot of them don't realize is that the first industry that gets transformed by 5G is the telecoms industry itself. And this is sort of, again, the 5G era rather than 5G technology per se. So we're going through a world where historically the cellular industry was a handful of national cellular operators, I'd say between usually 2 and 4 per country, maybe a couple of local regional ones in places like the US. We've had some tower companies and then a few virtual operators targeting consumer or IoT niches. What's going to happen over the next 5 years or more is that picture becomes much, much more heterogeneous, especially as the new spectrum allocations come in, the entry barriers fall with, it could be open source and open RAN and cloud-based core networks and so on. We're going to see some of the MNOs consolidate and merge. We're going to find that there's some new categories of specialist operators for rural or indoor networks, perhaps on a wholesale basis as neutral hosts. We'll find specialist networks for public safety, which might in some cases be contracted out to the MNOs. Vertical and industrial mobile operators are already starting to spring up, perhaps some cities, and then transports and transport service providers may well run their own networks or at least pay for them to be managed for them. And I think we see some interesting hybrids of mobile and virtual operators, perhaps with Wi-Fi footprint. The cable MSOs have a whole set of assets they can bring to bear and bond together. So I think it's going to be a very different and nuanced picture. That's got some interesting implications if you aren't talking about the valuation, or if you're a government that's looking at the competitive environment and trying to work out is competition effective, because all of the competitors are going to look very different in future. And I think that part of this is a shift to new wholesale models in cellular. Again, this applies indoor and outdoor. And I think this concept of neutral host for mobile will evolve from today's distributed antenna systems run by third parties. You'll see multi-operator small cells as a service in certain locations, both indoors or on campuses. You can imagine for business parks or new housing developments or large property developments where you have third-party service providers. You've got a lot of the property companies that are interested in their technology and connectivity assets and whether they can monetize them directly or in partnership. There's, say, the local councils and metropolitan authorities. And I think this sort of fits into a wider theme we're seeing of more B2B and wholesale models for elements of the connectivity stack rather than the overall telecoms industry. So last slide, looking at timeline. So we're near the end of the year. At the moment, there's a lot of work that's going on around private networks, certainly at a small scale or isolated in certain industries, but there's a lot of work that's happening with the CBRS in the US. The initial commercial deployments started a couple of months ago, and the full go-ahead for commercial deployments of CBRS should start early, either right at the end of this year or in January. I think that you're also seeing interest in CBRS from the mobile carriers who are looking at as additional spectrum, particularly for dense urban areas. So next year is going to be really interesting. So CBRS starts properly in the US, and I think it's going to be the telecom operators and a lot of interesting private innovation. I think that we'll see lots of experimentation, whether it's going to be, enterprise-wide or just as selected sites for individual use cases. I think that people will need to go down the learning curve. In the UK, where I am, there's some interesting things going on with localized spectrum. Again, it's going to be perhaps targeted more towards the in-building market for network sharing approaches. There's an interesting model for which is more network sharing, perhaps run by enterprises that are controlling passive or sort of rather non-spectrum driven infrastructure using a collaboration term which is Joint Operator Technical Specification, or JOTS, which is a collaboration between the main carriers in the UK to define specifications for shared networks in buildings. I think Germany has started in the last week or so providing localized licenses for industrial companies, and we're also going to see more Wi-Fi action, particularly if the 6 GHz band gets released. Going forward into 2021, we might start seeing millimeter wave rather than the existing 3G and 4G and 5G bands that occur. That's still unclear to me exactly what millimeter wave indoors looks like. I think there's going to be a long cycle before that becomes a mainstream thing. I think we'll start to see more of these vertical operators emerging and some of the neutral CBRS models. I think initially CBRS will be used for the carriers and pure private networks, with the neutral wholesale models emerging later on. And I think we'll also see a shift to what I'll call in a box approaches to 4G and 5G, of making it simpler and easier to deploy. And then beyond that, the crystal ball gets a bit hazy. I think we're going to see ever easier deployments, new and innovative channel plays. In theory, with 5G and some of these new core networks, we'll see cloud-based service providers that almost give sort of plug and play approach to private cellular. In theory, there are some people who suggest we'll have tens of thousands or even millions of private networks. I'm a little less bullish than that, but I think we'll see some really quite interesting things going on with the value chain. And then I haven't mentioned it much, but we can add in things like edge computing and a few other adjacencies as well. So I'll wrap up with that and hand it over and back to questions. If you're in London in February, I'm running a workshop on this, but contact me via email or my Twitter account or LinkedIn. So with that, I will hand back to Clarice, who has the questions. I realize I've run a little bit long on that. Clarice.
Yeah, cool. Thank you very much, Dean. We have some questions. So the first one I have from Matthias is, will private cellular system will be developed in non-licensed bands? And also in the registration form, we get some similar question, which was, is the private LTE because of unlicensed band used for 5G? So maybe you can cover both questions.
Yeah, I mean, we've had unlicensed 4G for a while, in theory. There has been not much use of it because the original standard for enterprise unlicensed cellular multifier wasn't an official 3GPP standard. With 5G, pure unlicensed enterprise-friendly use of unlicensed becomes more realistic, and I think we will see some use of it, but then the question is whether those organizations that deploy it are happy with unlicensed bands, which may face congestion and interference from other technologies. They're inherently less controllable. I think it's one of those things that if you're maybe running a railway through a mountainous area, you're not going to get too much interference. Or same thing on agricultural land, for agricultural use cases where you're perhaps looking to connect sensors or bits of farm machinery. Would you use this in a heavily trafficked urban environment? You'd have to be pretty certain of the use cases and the interference implications. But I think we will see more unlicensed used cautiously.
All right, thank you. The next question from Bruno Martucci is, do you foresee any use for underground rail public transit?
In a word, yes, and I think that depending on the rail network and what the infrastructure is like in terms of physical space for antennas or planning for propagation, there's certainly use cases for the railway's own use cases. It could be, I've seen this in rail networks generally, interest in private LTE to replace older forms of two-way radio, as I mentioned before, although perhaps given the difficulties with line of sight and propagation, it may depend whether a country has particularly low band spectrum. I'm not sure whether you'd use CBRS on an underground railway, and this is perhaps on the platforms itself in the stations.
Mm-hmm. All right. I've got another question about the legal challenges. So what are the legal challenges from FCC, FAA, like spectrum allocation, zoning, licensing, and also the legal challenges with national carriers?
Right. Well, here it depends which country you're in. And I think that certainly The CBRS band in the US has been extensively tested because it's a former military band. It's been the processes involved in setting up the SAS databases and the sensing capability systems has been extremely robust, and it's unlikely to face too many challenges. Elsewhere in the world, well, then it gets more nuanced and complex, and then you get into regulatory discussions and consultations. There's certainly some of the millimeter wave bands that people are talking about for indoor use. I had a discussion the other day saying, well, what exactly does indoor mean? If I'm in a railway station with one end which is open, is that indoors? Is it covered? What would I be allowed to use? Would the existing users, such as satellite operators, complain about that? So I think that each country and each band will have very specific legal issues. I think additional legal concerns come in if you're using the network as not just as private network, but interconnected with the public networks, and especially for voice and for smartphones. You run into requirements around lawful intercept, record keeping, and a lot more issues relating to the roaming rates, and you essentially there will be a lot more complexity if it interoperates with the public domain. So I think for that reason we'll see quite a lot of enterprises keep their private networks private, and use perhaps a separate overlay for public network indoor coverage, maybe with a dual SIM phone or something like that.
Yeah, it makes sense. All right, thank you. The other question I have for you, Dean, is are the carriers going to embrace revenue sharing for private LTE networks?
Well, an interesting question here is which direction is the revenue going to be shared? And I think it's going to come down to what organization and again which country you're in. And it's a very different situation if, let's say, you're a large Las Vegas hotel with thousands of hotel rooms. You probably have a bit better leverage to ask for money from the carriers to contribute to, if you like, the indoor roaming of their subscribers. Conversely, in some cases, the carriers are going to want to look for revenue to flow the other way, perhaps with manufacturing plants, perhaps where they're providing various layers of the stack, which could be managed security or multi-tenant core network or the eSIM management. And I think that the pricing models are still pretty opaque here, particularly the discussions between enterprises and the operators are going to be interesting, particularly where the operators have, in some countries, it won't just be one operator, but it may well be all of the operators who want to run some form of shared network or even shared spectrum infrastructure.
Mm-hmm.
And actually, related to that, one of the pieces of the stack we haven't even talked about is how you would do billing and charging. So even beyond the radio network and the core network is if there's people paying each other, you need a billing system for that. And we're still at the very early stages there too.
Yeah, true. We'll take a question now from Vikram Prasad from the webinar. Do you think that anyone outside of being a service provider would gain from providing services in the CBRS or private LTE areas?
Yes, certainly. I think property companies, tower companies. I mean, to some extent, you've got the old telcos and the new telcos. I would classify a future industrial network operator or a advanced property management company or oilfield services company as a quasi telco. They are service providers, but they may well be providing connectivity as a component part of a larger service. And to be honest, we see that today in wireless industries around the world. If you look at the satellite industry, there's a lot of people who embed satellite connectivity into, I don't know, environmental monitoring or TV broadcast or a bunch of other services. They are service providers, but behind the facade, there's satellite connectivity that's coming from someone. And I think that we'll see the same in Wi-Fi, and as we'll see the same in cellular. So I definitely think that, but actually one interesting one is a US operator called Southern Link, which is part of a big utility company in 6 southern US states. And it runs a big wide area private LTE network, and it sells critical communication services to other utilities and other agencies that require that coverage.
Okay, thank you very much, Dean. I think we're going to wrap up with this question. So thank you. I'm sure everyone now has a clear vision on private wireless networks. So a big thank you to you, Dean.
Thank you,
And also, I would
Clarice.
like to thank, yeah, you're welcome. I would like to thank our attendees for joining us on today's webinar. And if you're interested in the topic, please check out our private LTE ebooks, also written by Dean, which is available on our website and which really has also a lot of interesting content. And we hope to see you at the next webinar. Thank you,
Thank you very
everyone.
much.
Bye-bye.
Thank you, and happy Thanksgiving to all of our people, listeners in the US as well. Thank you. Goodbye.
Yeah, happy Thanksgiving. Bye.